I will be today's moderator, excuse me, for this really, really interesting panel. Before I get started, I'd like to welcome you to Battery 621. I have called this place home for my business for almost 5 years now, and if the physicality of a space can help to catalyze a business's direction and its culture, and if a space can influence you, then this place has influenced me in so many ways. It's brought the best out of our team and out of just about everyone who comes in the doors here. Where you're sitting now is the old Spider space. So this used to be filled with ski porn, all of the best gear you could possibly imagine from Spider. And so I still affectionately refer to it as the Spider space. So it's really neat to have an event here because so many amazing things have happened here through the years. We've had bands, great panels, and obviously ski porn. So with that said, before I get started, it's a Denver Startup Week event, and let us celebrate and acknowledge the sponsors that help make these things happen. Chase for Business, Comcast, and of course the Denver Downtown Partnership. Without these folks, our title sponsors, none of this could happen. So not just a golf clap, but a rounded applause. Very good. Super. I also want to thank my good friends at Mile High House. They are Tom Hogue here and Sandy T, among others, who are helping do some of the videography here. We have all signed some waivers here allowing our stuff to be sent anywhere in the world, and so we'll have some fun content here. I also want to thank Battery 621 and the ownership group here for allowing us to have this event. So that brings us to the panel itself. Is the hardware revolution real? I moderated one event yesterday. I sat on a panel this morning. I'm moderating an event tomorrow, and I'm sitting on another panel on Friday. And none of them are as eccentric or as unique as this panel. The group of entrepreneurs and innovators that you have on this stage is wholly different than I think what you'll see in any other event this week. And that's very meaningful for me. It's super meaningful just to be a part of Denver Startup Week, having been involved with it for 5 years, to see it evolve from something that's sort of pomp and circumstance and revelry to what it is now, to where it's really meaningful content, where we have incredible sharing, and it's just evolved into something that I think you guys all know and have experienced already this week. It's really, really special. So we're going to learn from these guys. Panelists, if I can encourage you today to find your vulnerable selves, to tell us about your story. And if you think you're going deep, consider going even deeper so we can learn what it is that you are made of, what it is, the words that your constitution lives by, so that we can best learn from you and not just be inspired, but actually have lasting words of wisdom to take forward. Does that sound good? Do you guys agree? Super. Likewise, it's important for me that our panelists find this experience to be rewarding, certainly, but also for you folks. So let us not get trapped into a sort of microphone pass around. If you folks have a burning question, an inquiry, stick your hand up or stand up or yell loudly. We want to make this interactive and fun. That's fun for us. It's fun for you. Am I making myself perfectly clear? Super. Great. So let's get started. We're going to learn about how these guys have created and innovated some of the most interesting products around. We've got Aurora represented, we've got Loveland, we've got Niwot in town, we've got Boulder here. So we've got people from all over the metro area. And I'm going to refrain from introducing them. I'd rather that you guys introduce yourself and get into some depth here with what you guys do and why it matters.
Great, well thanks for that intro. Thanks for having me here today. My name is Mark Spiecker. I'm the CEO of a company called Sharklet Technolgies. We use textures or shapes inspired by the skin of sharks to control bacteria on surfaces. So instead of using chemicals or antibiotics, it's a shape that bacteria don't like. So we're putting them on medical devices to reduce infections. We have some medical device and consumer products. We're starting to work with human cells as well to help improve other healing outcomes. We're located in Aurora at the Anschutz Medical Campus. Have the opportunity to regularly collaborate with the smart doctors and scientists on the campus there as well, and looking forward to sharing more of our story.
Awesome.
You want the vulnerable part now or later? All right. Yeah, sorry for this. But let's talk about my mom. My mom and I never got along. We never got along at all. We just didn't see eye to eye. She had this worldview of like things were either really good or really bad. Things were either like opera or like terrorism. There was no in between. She had best friends and she had mortal enemies. And I moved in with my dad when I turned 12 and didn't see my mom again for 10 years. And then like 10 years ago, when she was in the hospital dying of cancer, the staff psychiatrist pulled me aside and said, Eric, what was it like having a parent with such severe borderline personality disorder? And made so much more sense to me after that. One of the prime symptoms and signs of borderline personality disorder, sorry again for this, we'll go right back to tiny robots, is the notion of splitting. You see the world in terms of good and bad and black and white, and look around in the news, a lot of us see the world like that. Politics, red and blue, all this stupid stuff. And the world is actually made of lots and lots of complex things all interacting together. And oversimplified solutions, good, bad, labels, boxes, stereotypes, are super fucking harmful for society. So, we make robot toys. And they're called cubelets, and they're made of lots and lots of little tiny robots, and when you put them together, you are building a complex system with lots and lots of little brains. Instead of the typical robot, one brain, turn left, drive right, turn right, drive left, over a very simplified solution. So, I'm the founder and CEO of Modular Robotics in Boulder. We make these robot toys with the notion that giving kids tools, complex systems, little mini complex systems that they can play with, will help them develop intuitions about how the world really works.
So I've known Eric for, I don't know, probably 10 or 15 years, and I should know better than to be on another panel with him, because trying to follow him is pretty hard. Nathan Seidle, I started SparkFun Electronics roughly 14 years ago. So it's a little e-commerce business that sells these little breakout boards, these little sensors. So whether it's a luminosity sensor, or a barometric pressure sensor, or a little pressure sensor, right? Well, if you press on it, you get different resistance. We sell all those things on our website, and we design the boards, and we manufacture all the electronics in Niwot, Colorado, not because, yay, America, but because it's the cheapest place to do it every time we look. And so we found processes and ways to make these little electronics viable in the US, in Niwot, Colorado. And the reason why I do this is because I'm a geek, I'm a nerd, I never fit in, I never knew my tribe until I went to a maker fair 7 or 8 years ago, and there was geeks like me that were building stuff, and they were building really cool stuff, and I was like, oh my God, I found you, I'm not alone. So SparkFun has been around for a long time, and the reason why I continue to push SparkFun is because this story really got to me, but the 8th grader Ahmed who got arrested in Texas wearing a NASA shirt because he brought a clock that he had built to school. He got arrested because the administration thought it was a bomb, and because he was brown, right? This nation has a tremendous problem with technophobia and Islamophobia. And I don't know what I can do about Islamophobia except be friends with more people with scarves, but I can make a difference with technophobia. I can teach the next generation of technical citizens about this stuff, right? Is this dangerous? In the right hands, yeah, it can be. But no, that's not, anything we build can be used for good or for bad. So, SparkFun's mission is to teach the next generation of high schoolers how to use electronics for good, because I think we all need to know that to be successful citizens for the next generation. Cool, thanks.
You can clap.
So this is getting progressively more difficult to follow people, so my name is Harris Kenny. I work for Aleph Objects Incorporated. We're headquartered in Loveland, and we make the LulzBot line of desktop 3D printers. So just to get an idea of the room, can you raise your hand if you've ever seen a 3D printer in person before? Okay, sweet. Then our startup week, it's like pretty much every single person. If you didn't raise your hand, let me know after. like for the one or two people left, and we'll find a spot. So 3D printers are basically, they're a platform. They're the hardware that makes hardware. The printers themselves are a lot less interesting than the things that people do with them. And the thing that's interesting about our company in particular is that we're built on free software and open source hardware. In other words, we feel like we have a lot more in common with Wikipedia than a lot of the maybe traditional hardware companies that you think about that are making it harder to use headphones, for example. We instead prefer open standards, prefer developing technology collaboratively and ultimately respecting the user and respecting user freedom. So I'm definitely going to come back to that a lot, but we run our company with all free and open source tools. We use an open source ERP system. We use word processing, photo editing. The entire organization runs, and we've got about 120 employees. So it's not just a little garage shop, it's a full enterprise. And so I'm really excited to talk about that in collaboration, and there's a lot happening, a lot of innovation happening around open source hardware that I'm excited to talk about, including here in Colorado.
My name is Doug Greenlee, and I'm with SoundKinetics Labs, and we are kind of a little spin-off from an acoustical engineering firm that does the typical consulting, that sort of thing. And I grew up here in Colorado, and it actually kind of makes me proud to see all these gentlemen here and what they offer. And one of my big, I guess, things that tick me off, and this, a lot of times, innovation ideas come from being pissed off at something. It's like, why can't we do this? Or why can't we do that? Or you see a lot of cliche things out there. And it was several years ago, I was working my trade, acoustical consulting, and a typical problem is solved by what I call the inflationary model. And that is recommend the most extreme, safest thing you could do so you won't get sued. And going through a lot of these different things, I came across just a number of just frustrations. And it seems we were adding a lot to the expense of how you build a building, build a home, whatever. And so I teamed up with a company called Listen Audio, and we started to develop some products, and they're kind of platform products in the luxury space, which what I mean by that is in audio and acoustics, acoustic treatments and architectural audio. The problem with that is if we just stayed in that area, it would violate a lot of things that I'm trying to push for, is trying to bring the cost down, make things a lot easier. And so right now, we are working on a vibration control platform, kind of like a transducer stack that can be added to all kinds of different things, from motors to windows to all kinds of things like that. And so, here in Colorado, there are a number of acousticians, and it's kind of a community, a pretty tight-knit community. And a lot of them actually have kind of inspired me on this. And so even to just push forward, if you looked outside there, some of those acoustic treatment products, they're best described as acoustic Legos, and trying to stack them to have different characteristics. And and even to just change the subject a little bit, Eric, talking about borderline personality disorder. A lot of us, I think, are pretty obsessive. I'm certainly that way. We see a problem, and we really just really want to hammer away on trying to solve that problem. And technophobia, I mean, that's something I see all the time. I think of, some of the economists out there saying that. It's like, well, people are afraid of science, they're afraid of AI and all these different things. Actually, a lot of this stuff excites me, and I want to push the ball forward, and I hope these guys do too.
I think we've set the stage here for a pretty interesting group of people. I think you guys are great. I'm going to go forward without the microphone as long as you guys can hear me. Can you get that, Tom?
Yeah.
Good. Mark, I'm going to take it back to you since this just escalated as we went along with, considerable depth, and I saw you grab something from the floor. Can you share with us what that is? And then also, talk just a little bit more about but your products are truly inspired by nature, inspired by shark skin. I mean, the diver, or how did that happen, and then bring us back to what you're holding here?
Sure, yeah, thank you. So our technology spun out of the University of Florida. There was a professor down there that was experimenting with this idea of engineered roughness. Could he scratch up a surface and affect the way microorganisms would attach to that? The US Navy thought that was an interesting approach and asked him if he could develop textures to go on the bottom of their boats to keep algae and barnacles from attaching. So he got to work on that, and he failed just miserably. His first patterns made like algae and barnacles exponentially attach to these surfaces. So as a business guy, I would have thought we were all done, but as a scientist, he was like, well, if I can elicit a reaction one way, surely I can figure it out the other way. So he was down in Pearl Harbor at a meeting with the Navy, and he saw a submarine going out, and he's like, man, that thing looks like a big old whale. It's covered with algae and barnacles. He started to talk to some of the marine biologists, and he learned really that there's a rule of the ocean. And that rule is that things that go fast in the water, like dolphins and porpoises, stay all nice and clean, where things that go slow in the water, like whales and manatees, get fouled. Algae, barnacles, other kinds of growth. Sharks go slow, but for some reason stay clean. Scientists have tried to figure that out for years, but it wasn't until this professor, Dr. Anthony Brennan out of the University of Florida, had a friend catch a shark, took a dental impression of it, looked at their skin under a microscope, and figured out that the reason they didn't have things stick to them was because of the shape of their skin. So he modeled that mathematically, so certain physical and mathematical patterns in the skin that aligned with these models he was working on for engineered roughness. So he took the best parts of shark skin, put it into his model, cast it in some plastic, and then he tested it. And he got about an 85% reduction in algae growth and a 97% reduction in barnacles on the first try. Really excited about that. But then it got really cool when he tested against human pathogens. So we hear about bacteria like Staph A, Pseudomonas, E. coli, things that cause anything from nasty skin infections to stomach aches to food poisoning. And he found that those kind of bacteria have trouble attaching to the surface also. And the weird thing about bacteria is they only live about 18 minutes or so. They have to replicate every 18 minutes or so to survive. And if they can't attach to a surface, they won't replicate. So if he could create this surface they don't attach to, he could keep them from replicating. And if we can keep them from replicating, we think we can keep them from getting to a point where they can cause infections in people. So we got to work. So this all sounded really cool. So in 2008, we licensed this technology from the University of Florida. We got to work on that. We then found out that it's really hard to make features that are about 2 microns in size. 2 microns is about a 50th the size of a human hair. And there's really, other than the computer, microchip industry, with $1 billion machine making something that big over and over again, there was no technology that made textures or shapes of this size. And then in 2008, 2009, the markets collapsed, all the venture capital dried up. There was no really way to fund a health medical device company. And I don't know what your guys' companies cost to fund, but to bring a new medical device to market, you're looking at somewhere in the neighborhood of about 12 years and $50 to $100 million. So you need a lot of capital to figure out how to do this. So, personal challenges, as I've been at it for 8 years now. We've raised a little bit of money, about $6-7 million, and then we've funded through government grant programs. So you get like a phase 1 grant for about $150,000, you get a phase 2 grant for about $1.5 million. We've been really successful. We just got our 12th one of those for about $10 million, but they only get you so far. We then do a lot of joint development projects with large companies that take a little while to get through, and usually by the time we show that we can be successful, the company gets bought, or there's a management change, or people get a little too nervous to invest that next $5, $10, $20 million that's needed. So I didn't have any gray hair when I started this journey about 8 years ago. My kids tell me I have a lot now, so that's a little struggle in there as well. We feel like we've really hit our stride now. We just announced a big partnership with a company that makes a product called Release Papers, a company called Sappy Fine Paper. They're about a $6.5 billion a year paper company. They make papers that you would cast leathers off of, laminates, wallpapers, so really any high-touch surface you come in contact with, starting in the first quarter of next year, they'll be available with this texture on them that'll reduce bacterial transfer by about 97%. We also have a big medical device company that we've got a urinary catheter that's in clinical trials right now that we're hoping is going to reduce infection and save lives. And then what brings me back or qualifies me for the hardware revolution panel is that we just got a grant to develop a wound healing device that we're planning to 3D print. So we're developing a special material that you can 3D print, and this is a model of what it looks like. Essentially, it's got this capillary structure inside in the bottom of it, and it's got our pattern, diamond-shaped Sharklet pattern on the top at a larger scale. And what this does is it induces blood vessels to grow in the wound, and then it uses a pattern to be able to cause cells to grow faster across the top and close that wound faster. So we're working with some big companies right now to develop 3D printers as well as material that you could 3D print and put into somebody's body that would essentially help improve that healing effect and hopefully heal folks faster. So, thank you.
Yeah. One of the things that's really evident to me as I hear all of your stories is just how important what you guys are doing and how much, like, it seems like bottomless passion you have about it. Harris, I wanted to ask you about how the open source nature of how you guys develop and build hardware affects your culture. So I own a technology staffing company, and when we help to grow companies, their culture is very, is a key piece of how effective we can be. They're mainly software companies. So I'm curious about hardware companies' culture, given you have different types of people in there. My understanding, by the way, so that you guys won a certificate like the right, freedom, I wrote it down here, Respect Your Freedom Certificate, the first ever hardware company ever to receive this. And that seems to be something of a pinnacle of the culture that you guys built. Tell us more about how it seems like you're shitting and grins. So
Yeah. Well, we're super. Yeah, I can't speak to my lunch, but we had it was a great privilege. So for people that aren't familiar, the Free Software Foundation has been around for a little over 30 years. And the open source and free software world, that revolution has been underway for a long time. But only in the last 10 years or so, 10 or 15, have those ideas started to really play in hardware. And so the biggest thing about our culture and when it comes to our products and our folks is that there's I think a very deep sense of humility. We recognize we stand on the shoulders of giants, as the saying goes. Many people have come before us, and we are now kind of contributing to that global effort to make cool things, to make technology better, to solve problems. At the heart of our machine is types of electronics called Arduino. SparkFun, for example, has been increasing access and doing education and providing tools in Arduino for years. We use Arduino to power our printers. We also use, if you're familiar with Linux, we run GNU Linux workstations throughout our company. We use free and open source 3D modeling software called Blender and FreeCAD and OpenSCAD. And a culture where you're built on sharing and sharing information, the first instinct is to ask someone else if they have an idea, to see what other work is being done, to try to find collaborators. And then if you find something cool, something interesting, whether it's a faster way to 3D print something or a better way for us to manage our inventory, the first instinct then is to share it. And to really build that in from day one, where information is not something that's scarce, it's not something to be politicized and used for personal gain within the context of a company, where people can kind of hoard information to empower themselves. Instead, it's really the opposite. The people that are more effective at sharing, and more effective at communicating, and more effective at collaborating are the people that are really successful in our company. And we've got a lot of folks that do that really well. And other folks that have a little bit of a culture shock, but then get the hang of it and they're like, oh my gosh, this is so great. Our engineers can just say what's wrong. They don't have to worry about like hiding it and putting it in the right way. It's just like, hey, we got a problem. This isn't working, Or if we don't have a part, or if part came wrong to spec, we just talk about it,
it doesn't become this like political thing. So, I mean, our challenges are not about open source. Open source makes our business a lot easier. Our challenges are just building physical things that have components that need to get shipped. Customers need help because something breaks. Like that, the hard part of our business is the business. I think the open source side of it makes things easier, and I'm sure that Nate will be able to talk about that a lot too.
Nathan, what about you? SparkFun. So, SparkFun, there's something to the name, SparkFun.
Sure. Yeah. I mean, so the name comes from 2002. I was building something on my desk, and I was moving stuff around, and I had this very expensive piece of equipment for a student. I was a sophomore at CU. It was $150, and I had to take out student loans to pay for my entire education. So $150 was a lot. I was moving it around. I accidentally set that piece of equipment down on a bit of wire. There was a spark. There was a bit of smoke, and the entire thing burned itself down. Right? Well, at that time, I was really pushing myself and learning something new. So at the same time that there was a spark and there was destruction, I was having the most amount of fun I've ever had. Right? So SparkFun. Sometimes sparks can be fun. And the domain happened to be open. So that's where SparkFun came from. So mostly, I mean, we have, I don't know how many collective years of stories up here. I don't want to talk. I want to answer questions. Do you guys have questions for us? Because I've got 14 years of crazy that I would love to share with you guys. That ask us anything you want to know, and we'll make something up. I better have 2 mics.
Gentleman in the left with the blue shirt, I'm asking to speak up. Right there.
I have a question. You were talking about open source branching to the market. I've been talking about it for 25 years. I've seen agile development on the software side, trying to branch more to the hardware side. Has anybody solved the problem of lead time on prototypes on hardware? Because as far as schedule, with that, on your projects, the biggest problem is even in the coding process, waiting for people to get a code or a prototype, sending it out, getting it back. You're talking 3 weeks to get this to compile a hardware plan overnight. You know, I know there's paper printing circuits, things like that, but has anybody dived into that? Or, as far as, is anybody out there doing it more successfully?
For the purposes of responding in the videography,
Repeat the question.
Answer the question. Or,
So, if I can take a stab at it, how have we approached the prototyping process and tried to make that as lean and as fast as possible? So, you know, these things start out as prototypes, and you got to get it to market as fast as you can because your competitor is going to have it out there. And so, our current critical path is 110 days, and we believe we can get that down to 70. The way that we do that is to clear out all the bureaucracy, and it takes. It's funny. My people are trying to be penny wise and pound foolish. So they're trying to save $45 on a solder stencil when, like, come on guys, like just pay the $200 and get it overnight. That will allow us to get to market 3 weeks faster, and we'll sell thousands of dollars worth of parts. So it's really getting alignment within at least my company, showing folks where the expense is and where that's going to be long term, if that makes sense. And just to play off to Harris, we're fully open source as well. With 500 products, they're all on GitHub. You can take this, you can modify it, you can copy it, you can sell it, you can do whatever the hell you want with it. That means that I have to come up with a better feature, a better product, a better something every 12 weeks. 500 products every 12 weeks. Go. Right? That's what open source does for you, is it never lets you sit on your laurels. You can't sit still. You don't have patents. Do you have a cell phone? Does it look different from 3 years ago? Because patents take 3 to 5 years to get and $30,000 to $50,000. I don't have the time or the money. No, I got to go build some stuff. So yeah, me and Harris are cut from the same fabric. We're very much open source folks. So yeah, we can talk about open source too.
Yeah. Prototype. Yeah, so on prototyping, one contribution from the open source world is modularity. And so that's something that we've seen where we identify, hey, 85% of this machine, we're pretty darn confident that that's not going to change. So let's get that out there, and then we focus in our prototyping on the components that we do want to iterate on. So in a 3D printer, for example, you've got the tool head, the part of the machine where the plastic, for our printers, where the plastic is coming through, where you can do a bunch of iterations on that small component, and we do smaller batches. So we do batches of 2 to 3, 5,000 machines or something like that, and then we iterate and we do sub-generation. So if we've got the Lulzbot TAS 6, within the TAS 6 there could be a 6, 6.1, 6.2,
So that's one way, two ways, I guess, modularity, small batches. And then the third most important way is getting the files out earlier. So we've had products that are still in development that our customers have already built and given us feedback on. Every 30 minutes, our whole R&D archive, it's like a Dropbox, but with no doors. Anybody can see every 30 minutes, every single R&D file, every single bill of materials, every single model, everything we do is updated publicly. And so we had a customer on the forum be like, hey, I saw this tool head, I built it, you might want to change these things. You know, and most marketers would be like horrified, of like, it's not supposed to come out for 6 months, what do you mean you built one? So those would be the three things that we do to tackle that problem.
Question right here. Question, stand up.
Question for Dan. For use applications, how do you prevent the Sharklet technology?
Mark.
Mark. Sharklet.
Yes.
If people are touching the stuff, how do you prevent finger oils from ruining your product?
Yeah, it's a great question. As far as the touching goes, we've observed that the texture has a little bit of an oleophobic effect, so it resists the oils, it kind of pushes them out. The surface is also hydrophobic, so if you think of when your car gets washed, freshly washed and waxed, the water beads just kind of roll right off of it versus before that and they splotch out. A lot of the magic of our surface is that those water beads will just roll right off. So just like the bacteria, just like the water, the oils seem to have trouble sticking or attaching to the surface, and they just kind of wipe right off.
Good.
Can I add to yours?
Eric, sure.
You said so many cool things during your. I have like three things. There's the biomimetic stuff. There's the NSF SBIR grant stuff. We got a lot of good stuff to talk about. But an interesting anecdote. You're doing biomimetics. You're looking at the natural world and using it as inspiration to develop technology, and that's super powerful. When I was a grad student, I worked in a lab called the Micro Nano Robotics Lab, and we were studying geckos. The whole lab. It's a robotics lab, and we were studying geckos. And if you've been to like Central America, you see the little geckos and they're on the ceiling and they're everywhere. They're on glass upside down. Their feet are not actually sticky though. Like it's really weird. If you pulled a gecko down and you pushed its little feet, they're not sticky. There's no adhesive. There's no gunk on there that makes them stick. They're completely dry. And people have been, unfortunately taking apart geckos for like 100 years to figure out how they can do this, right? Because, military or whatever, or medical devices, little like things that crawl around inside your body, everybody wants to make non-adhesive, sticky things like geckos. And they finally figured it out like 5 years ago or something like that. It's atomic forces. On the bottom of each gecko feet, there's this whole pile of little hair. And at the end of Sorry, I feel like I'm creating feedback. At the end of each hair, there's like 1 million more little hairs branching out in this hair-like structure, and the hairs get so thin and fine, there's so much surface area, that van der Waals forces, like atomic forces, are actually causing these hairs to stick in each little crevice. Amazing, amazing stuff.
Yeah, and the whole looking at nature for inspiration, that started with Velcro. Similar to that, right? A guy was walking his dog through the woods, and he got those little burrs on the dog, and as he was peeling them off, he thought he could make something synthetic about that. So, and as you look around, there's lots of other examples of, the bullet trains that are modeled after the birds' heads to make them go faster. There's a tape that's now coming out that's based off of the gecko feet that people can buy and use to attach. And then those design principles are being put into all kinds of other things, from airplanes to cars to cars that if you get hit by them and you start to roll, they'll catch you and stick you to that surface so that reduce injuries. So lots of inspiration in nature.
Doug, I want to credit you for, Doug over here in the corner, he really assembled this group here together. And as this thing is starting to unfold and I'm just going, what is going on? We're talking about inspiration. What inspired you to bring this group together and to talk about what we're talking about? Because you've got the gumption too.
Well, it really comes down to companies that are not cliches, that are doing something I think is important. Everybody, the open source movement is something I definitely believe in. And I've been trying to wrap my brain around even what we're doing. How can we do this in kind of the acoustics field? And it's inspired me actually, and I kind of knew that. It's almost like teaching. When people volunteer to be a teacher or just become a teacher, they almost learn more from their students than the students learn from them, or I don't know exactly how that works, but I always hear that they learn a ton by just becoming a teacher. And for me, on this panel, I knew that just kind of looking up to seeing all the things that they're doing, I knew I'd get ideas. It's about inspiration. I mean, just, geometric shaping things. I mean, that's something we do in acoustics all the time. That's something I do in the product designs. And just even the little transducers and different things that these guys use, that's kind of my field. And we're applying these things, trying to solve problems. And so, really, and it excites me as a person that grew up here, of trying to push the ball forward on technology and educate people and get people to think a little bit differently. Culture was touched on. Working as an acoustical consultant, we are thrown into all kinds of teams. And we don't have a choice a lot of times. It's an architect, it's a general contractor, it's everybody. And you try to get along with those teams. You're kind of forced into it. And you try to come to, an agreement. Now, having said that, there's usually always a core team that, if you spread it out too much, then there's going to be a lack of innovation. But so by taking that and just kind of looking at what I think is down the pike, so to speak, and seeing these companies, their cultures, I think, are what the future holds. I mean, I think really this is how people should work together, almost respecting each other as, just almost like individual agents. Every person, instead of the typical top-down kind of approach. And so that was one of the things I was thinking about. How do you collide? It's almost like a collision of culture with innovative products. Well, it usually starts with culture. That leads to innovative products. And if it's a really good culture, the more innovative it'll be. And so I guess, I'm meandering here, but that's really sums it up, I think.
No, I think that really reflects the spirit of what Denver Startup Week is all about. Like, just, what do you do? And then it's like, what? Like, seriously? And then you just want to find out more. So, no, I applaud you for putting this group together. Do we have any other questions, particularly if we can find out what makes these guys crazy, because they're like chomping at the bit to talk crazy. But no matter what your question is all about, let's hear it. Stand up, please.
Sorry, I hope it's a good one. Specifically for SparkFun and Modular, I guess. I think of like Denver as being kind of an outpost in the technology industry as it is. And then, Boulder, I think is in the same way. But then to put your companies and your life basically out in Niwot and then even further out in Loveland, like has that caused you any issues in like growing the company? Like people just don't know where Loveland is and engineers don't want to live there necessarily? Or put limitations on maybe partnerships that you have where people are like, I don't want to go to the middle of northern Colorado. Like I never heard of that place. You must not be a very serious company, etc. So I think a lot of us moved to Colorado for like all the great things it has to offer, and that includes like outpost cities that are not really on everyone's map. And so I just was wondering if like that affects, if that's like has ever been a drawback for your companies, if there's ever a time when you said like, I wish I would have just started this in Seattle or.
Let's face it, nobody knows about Colorado, period, right? It's like East Coast, West Coast. They're like, Denver, that's in the middle somewhere, right? And so the fact that we're in Boulder or Niwot, it doesn't matter. I think what matters is, for us specifically, we started in Boulder. Boulder got too expensive and we got too big, so we've been moving out. But that's a good thing, actually. The closer we are to Longmont, Lafayette, Louisville, Loveland, I mean, all the it's weird, but yeah, that's where people live. And so they come, and it's better for them. We get a better workforce. Being close to the university is awesome. I think Colorado's a great place to be and to have a business, and like the rest of the world, whatever. I think what's most important is your culture. You have a certain workforce on the Front Range, and by having a good culture, you can get people to uplift themselves.
So last time you guys have camping out, people waiting for jobs and groupies and stuff like that?
I like that story. Yeah, we have that all the time.
Is that true?
No, I don't think so. But we said about it, right? Long time ago, we've had contests. We've had, hey, here's this piece of hardware. We have no idea how to make it work. And the first person to take a picture with it, it was a camera that we found that was super cheap. And we have no data sheet. We have no specs. If you can take a picture with it, then we'll give you $1,000 in an interview. And it took about 3 months. And there was this crazy Canadian that figured out how to make the camera work. And he took a picture of himself. And he got an interview and eventually got a job.
Awesome.
If I could jump in real quick, I'd also say that there are still a few aspects, I think, where Colorado is a flyover state. You know, being in the bioscience industry, I have the honor of chairing the Bioscience Association in Colorado. We've got like 700 biotech companies here, and it is hard to fund them. It is hard to get the venture capitalists to land in Denver and get engaged around writing checks. But Denver and Colorado, to some extent, though, the secret's out about how great it is. I mean, I think we're ranked #1 place for women to start a business, #4 in general to start a business. I think we were #1 most business-friendly state. Something like 80 or 81 new millennials a day are moving to Colorado. I mean, it's just a significant number of people are moving here to start businesses and to grow, grow their companies. So there is a lot of excitement and a lot of interest here as well, I think.
Keep it going. And that was a great question, by the way, so thank you.
Great question. Nice shirt. I live in Nederland, Colorado, actually, which is a super weird place. But to tack onto that a little bit, like I have to run out of here right at 1:30 to get on a plane to go give a talk in San Francisco, and it's a national conference for tech and venture capital and stuff like that. And I'm coming from Boulder. I'm the only company not from the Bay Area. So it still is a little weird. People still think we're from outer space. But this is the best place to start a company. We have the most amazing people who are willing to work for far less than they would in the Bay Area and who end up being pretty well balanced. They go hiking and they go climbing and they go skiing and they come in on Monday kind of refreshed and ready to do their work, and we don't see much burnout at all.
And so I think I'll just add to a lot of good points here. One, Loveland's great. If you've ever been to Loveland, you should check it out. Lots of, so there's lots of great towns and things going on. But I will say, so we were just ranked on the Inc. magazine, Inc. 5000. We were the #1 computer hardware company in the United States, which we were really proud to achieve. So we're growing a lot, and it's not just us, it is companies like SparkFun and everyone here on this panel. What we've found, so we manufacture in Loveland as well. We've got a 17,000 square foot building, so we have 7-day-a-week production. Folks are working every day of the week making our printers. So we need support for things like laser cutting, wire crimping, powder coating, all the kind of little things that go into making a consumer product, packaging, box printing. By the way, if you want to hear like, packaging sucks, okay? Like, if you want to do hardware, like, spoiler alert, that's like maybe the hardest thing in my opinion. And these guys, like, they're groans, I think, agree, and it's like the last thing you think of, but packaging is really tough. But there are some good vendors that we're working with. So, we have a whole world of vendors that we work with that are on the front range, that are doing great work. And that's really important, having local partners. We've got great folks coming from the universities. There's hacker spaces like Loveland Creator Space and Den Hack, which is about a block away. There are libraries that have basically maker spaces, hacker spaces in the library. Denver Public Library does a great job with that. And then, of course, it's easy to convince people to move here from other places. And so we have had some folks that are in more specialized position. We're like, hey, do you want to move across the country? And they're like, yeah, actually, I've wanted to move to Colorado forever. Can I start in a week, kind of thing. So anyway, that's kind of a short answer. I'm sure there's some challenges, but that's pretty low on our list of problems, I guess, is maybe another way to say it.
I'll take just a quick stab. One thing about the history of innovation, and I'm a history buff, people always assume that big cities, that's where all the innovations come from. It's usually not the case. Even dating back to some of the clusters of great inventions like in the 1800s, these were all small cities. They were small towns. A lot of these great innovators came from small towns. And a lot of them grew up on farms. And they knew how to kind of make things because there just were not things available. So they had to improvise. And so what you'll find, even Silicon Valley, I was born in Los Gatos. A lot of those were small towns. They still are smallish cities, but they were small places. They were not big. They were not San Francisco. They were small towns. Now, they were connected. I mean, there were labs around there. There was all kinds of ecosystem, obviously Stanford. And it's very helpful to have universities. It's very helpful to have labs. Access to capital, that's another one. That's a big one, obviously. But even still, you could pretty much, it depends on what your niche is, depends on what your product is. You can do something, from our perspective, we're an R&D firm. So we can use people all around the world. Now, a lot of times prototyping happens here, but this is something that can actually even happen 24/7 too. So it can be anywhere, really.
You had a question up front?
Yeah, I was going to ask, maybe if we could just broach the topic of copyleft and open source versus protecting your IP and time to market and miniaturization, since we have SparkFun in the house. So I could do a little prototype, right? But then let's say I want to miniaturize that and I want to protect my IP, but I also maybe want to have an open platform and engage with the world at large. How do you navigate that space?
Cool. Let me phrase your question so I think I understand. You want to build a thing and you want to protect it, but you want to have basically an open SDK or an open platform?
Something just navigating the space between, obviously, material science. Okay, this is patented. We got this from the research department. Now I need whatever else this. Versus okay, I prototype this and I have my Burning Man store online and you can buy my LED jacket.
Mm-hmm.
How do you go from prototyping Arduino to miniaturization? Like this company, Synchronous, people might be interested in.
Okay.
Let's say I get an idea. This is a time to market company where if the idea is validated, she told me, almost no one pays them out of pocket. Their ideas are already validated. It's just a matter of reducing time to market. So obviously, if we're selling something, you're going to be a core IP. So how do you navigate that?
I guess, forgive me if I don't understand your question, but the way that we approach making money is by selling it for more than we made it for. It's this crazy business model. Right? I build something for $10, I sell it for $20. And I put it on a website, and I say, here, would you like to buy it? That's it. That's the secret. There's nothing more to it. Do I need intellectual property? Do I need patents? No, I just need customers and things to sell. So, I don't, that doesn't answer your question, so I don't understand it yet.
Well, so you might have heard BeagleBoard.
Oh yeah, BeagleBoard, yeah.
Right. So before I even knew about Arduino, I knew about BeagleBoard.
Cool.
And so if I was going to prototype something, obviously transistors get smaller and smaller inside the IC.
Yeah.
So at some point, do I
So you're talking about the integrated circuit is too small to prototype. You've got to go to a fab house to have it manufactured and all that fun stuff.
I'm just broaching the topic. So for instance, Apple, their stupid lock-in with headphones. Okay, fine, but I like Apple's stance on privacy. So I like Apple's walled garden,
Okay.
So I just wanted to maybe broach the topic of IP and in an open platform kind of sense.
Can I ask a question? So are you is what you're trying to do kind of start a design and then put it out to the world to let them finish it, but then try to maintain some exclusivity that you're the one who gets to go make it and sell it?
Well, forgive me, I don't really know everything that I'm doing. I have some Arduino at home. But I just thought it would be interesting to approach the topic of intellectual property and innovation.
I'd be curious if what I just said is possible. That would be pretty cool. In the bioscience industry, we have to patent things. We spend $100,000 a patent to get them issued, through the process, and we've spent a ton of money on that.
Why do you have patents?
In the medical device space, the cost of capital to get it to market, I've got a catheter down here that's going to cost $40 million to get to market by the time it's done, and you won't over a 10-year period. And if you don't have IP around that, you'll never finance it. Nobody's going to give me $40 million to be able to make that product. So I think there's certain industries where you have to maintain patent protection. If there's industries where things are obsolesced before the patent would even be issued, let alone go through that process, then I think you probably don't need a patent. You probably want to just keep iterating as fast as you can with the next generation product.
I will cordially disagree with you. I think the issue that stems from that is, okay, it's $40 million to develop this catheter. I don't have $40 million to develop a catheter, so I'm going to come up with processes and ways to go about it. So I feel as though the demo, the process in which you develop, if you have too much funding, it can lead to inefficiencies. And so I wholeheartedly believe patents lead to inefficiencies. A false monopoly makes things inefficient, and by not having that safety net, we're gonna get creative. We're gonna find ways. If I don't have the money to do X, Y, Z, shit, I better figure out a different way to do it. So I don't know, that's just my approach.
Since I'm sitting in the middle, I'll try and do like a little third way thing, which is the way modular robotics works. We do patent some of our technologies. We have patented a couple of different things. It's not because the patent system is good. I firmly think the patent system sucks, but we've gotten some grants from the National Science Foundation, and one of the main metrics of success for big government agencies for the National Science Foundation is showing that you've gotten patents. Thank you for your $1 million. Look, we got patented technology with it. It was a good investment in us. So we've done that to be able to get more grants. I struggle a lot. I'd like to do like an impassioned defense of the closed source hardware movement, but I don't think that's possible. But I do struggle a lot, not with the licensing and the legal stuff between open source and typical like closed source development models, but like the ethos. So kubelets are basically closed source. We don't open source the hardware, we don't open source the software. It's a typical consumer hardware product. And I struggled with that for a long time because I look up to SparkFun as one of the most amazing businesses in the world and everything that they've done with open source. You guys, so many great companies around here and worldwide doing great open source hardware. And so I struggled with the notion that like open source hardware, licenses aside, is all about empowering people with the freedom to open stuff up and remix it and learn by playing around and redesigning and pulling things apart and learning by taking things apart. And at Modular Robotics, we're literally taking complicated hardware and software and wrapping it in black boxes, literal black boxes, doing the opposite. And I struggled with that for a while, but I think that's okay, because where typical open source ethos is pull it apart, remix, learn on your own, build stuff, the black boxes approach is the approach of construction kits, providing people with a very carefully curated walled garden kit of parts, like Lego or like a Rector set or something, that allows them to abstract away things like connections and data and physical joints and things like that, and work on the level of complex systems and networks and control theory and graphs and stuff. So all that can exist simultaneously, I think.
I've just got a few different thoughts on this. So I can really best speak to my experience at Aleph Objects with Lulzbot 3D printers. So for us, in our experience, it's about execution. So there are over 1,000 desktop 3D printers that we compete with in the market. We make 2. So it's a very fierce market. Over the last 3 years, we've been steadily climbing up. We're, depending on where you look, 5th, 6th in market share in the desktop market out of a lot of companies. And that comes from good execution. So then the question is, what environment is conducive to good execution? And for us, an open environment has been really good for that. Now there's also the ethical argument about user freedom, which is important, but just kind of for the sake of your question of like, hey, I've got an idea, how do I bring it to market? We think that's good. It's worked out really well for us. And I think no matter what how many lawyers you have or don't have, execution matters. I think a lot of folks agree with that. And the other 2 thoughts, so I don't know med device, so I don't want to step out, but there is an interesting company called Emerge Medical that was started in Colorado. They basically, about 80% of the surgical devices, this is my understanding, so look it up if I'm wrong, yell at me on Twitter. My understanding is about 80% of the market patents had expired, and so these are things like hips, knees, joint replacements and stuff, and they basically realized, hey, there's this gap where salespeople are taking doctors and medical professionals out to golf, to steak dinners, and they're doing a lot of really expensive things to get those sales, and that's jacking up the price of the devices. So we can actually manufacture those devices for less, cut out the middleman, middle people, and sell direct to hospitals and hospital systems. And they were acquired by Cardinal Health, which is I think a Fortune 5 or 10 company. So they built a very successful company. They were sued almost immediately, by the way, like the day they went into business. But they won the lawsuit, and they were acquired and built a great business in med device
without patents, almost explicitly without patents. So that's one idea. And then another thought is that Tesla did and is moving in a direction of openly allowing use of their patents to develop a platform. Now, are they as super hardcore as some of the open source companies? No. But their incentive is basically they want to set the standard, and if they are the ones that are leading in technology and they allow a platform that other people can talk to and connect with easily, then they'll set the standard. And so they don't just have to sell their batteries and their chargers, they could sell a battery to every car company, and they could sell a charger to every gas station kind of thing. So anyway, two alternative looks, but again, I'm not a lawyer, I'm not a patent expert, so I'm better at talking about 3D printers, but maybe look that stuff up on DuckDuckGo, which is a good privacy-respecting search engine.
Actually, I do have probably a question for all of us, and Nathan and Harris. You know, I think what you're getting at is that there's got to be some workarounds. Like in the highly regulated areas, this is an opportunity, obviously. And it might take a lot of creativity and a lot of pain, but workarounds that can be an alternative, the open source alternative. And it might not be obvious right now, or maybe you could touch on that.
What you said, yes,
We've got lots of questions. I'm getting a hip replacement next week, so I hope those good guys have got their hands on this thing, because if I could talk to it and communicate with my new hip. Ma'am, what's your question? Can you stand up, please?
Yeah, I have a question about manufacturing and 3D printers. What's your, those of you that are making your widgets, what's your biggest challenge?
So we've 3D printed over 1 million production grade parts that are used in our printers. So when people say, like, what's the coolest thing you can print, I always say more 3D printers, which is like a very cheesy answer, and I always feel guilty saying it. But the biggest, I think the biggest challenge with, when you start to get more printers, all of a sudden you have to hire like printer techs if you're using a printed part in your final production. So if people get to a point where they're like, all right, we've got 3 or 4 and we can't just have this one person running it in their part-time. We need to actually hire a full-time person and do it. And if a company's willing to invest in that, we've found it's cost-effective for scaling up production. And we have 156 machines that run 24/7 printing parts. But that's obviously, that's a whole department of the company, and they've got their own purchasing processes and their own production. And we've got a free software tool chain that if you want, you can replicate that we use to run that. But that's a whole investment decision. Typically, people get to a stage where they have to decide, like, do we want to keep printing this or move to injection molding? For us, injection molding has been expensive, so printing has continued to make sense. But there are print services. There's a company called 3D Hubs that you could work with to potentially have a network of people print parts. If you get to the point where it doesn't make sense for your engineer, you want them doing the next prototype, you already have your part finalized, then you can shop out, and as access is increasing, there's other people that can do printing for you if it's a simple component. So yeah, I'd say that's kind of the quick answer on how we use it. And we also use it for jigs and things like that, not just parts, but also on the production line. 3D printing to make custom jigs and fixtures to actually make things so the printed part is helping hold 2 pieces of metal in place, or it's used to make sure that a bracket's aligned. So it's not necessarily printing a part, but printing a part to build a part.
So you asked what the greatest challenge was for making things, like manufacturing and selling stuff. I think you talk to any of us, and we're all going to have a story where you talk about packaging. You know, I have this product, and it's totally built, and it's ready to ship, and oh crap, we're out of plastic bags. How are we out of plastic bags? The 5-cent thing held up the $20 retail item. Right? And so we're talking about not bits, we're talking about atoms, physical things. And so we all have different systems to manage our inventory, but you can't just say, oh, well, I'll buy 1,000 of those cheap things and I'll never have to think about it again. You have to think about every piece of the thing that you're building and manage that inventory. It's logistics, it's ERP software, it's really mundane. But it's what we have to deal with day after day. I have, the sensor on this board is $5. The stuff that goes around it is half a cent. Okay, so of course we're watching the sensor and we make sure that we have the sensor in stock. But if that half-cent thing goes out of stock, it blocks profit of $20,000 a month. right? So I have to keep track of not just the $5 thing, but that half-cent capacitor to make sure that I never go out of stock of that. It's logistics. I wish I had a better answer.
Keep rolling with Q&A.
Yeah.
Sir, let's step up.
So talking about, I have a 3D printing background, but this is open for any of you. Nathan seems super jittery about it too. So going from mass production to kind of mass customization, and we have 3D printing continues, we're printing printers. And you have the Internet of Things, which is attaching devices to everything. As this all kind of funnels down, what's kind of the chasm that we need to jump over? Is it a material side? Is it a capital, networking, patents, hardware? What's kind of like the last point?
I'll give one. I mean, for us, it's speed. So Modular Robotics would not be here without 3D printing. When I started grad school, this 3D printer was delivered, and as per your question, the old hardware prototyping cycle of send off your CAD file along with $1,000 and wait 4 weeks to get your part and then realize it's wrong and do it again was changed into draw a little something before lunch. Press print and go out, come back from lunch, and there it is warm, and play with it, and draw something again, and go get a cup of coffee, and there's your latest version. And we did, all this prototyping so quickly. We don't use 3D printing for any sort of manufacturing or anything like that, or mass customization, simply because speed. The 3D printer that we use to mock up cubelets and jigs and fixtures and everything is a $50,000 3D printer, and it costs a couple $1,000s a month for maintenance, because it's a very high resolution, super fancy 3D printer that can do these little farkles that some of the desktop 3D printers cannot. And it takes, an hour to print a cublet. And we injection mold our cublet shells for mass production, and it takes 1.5 seconds for each cublet to right down the line. So for us, it's just speed.
So if I'm understanding the question, it's like kind of what's the next problem that needs to be solved too around physical hardware?
I'm just seeing kind of a trend go from mass production to that mass customization, and people are customizing and printing and making their own things. So as like businesses continue, like how are they going to kind of come about? Is it an education about the space? Is it just the processes that are there people aren't aware of, or is it he said speed's kind of like to get to that point. So
I think the other thing is I think some brands and some products that are succeeding are doing a good job being open for business in terms of like sharing information, so that the early 3D printing is still a little specialized. And so, Eric's been using 3D printers for years, and he's a hardware entrepreneur, so he knows them really well, but there's a lot of people who don't. And so the idea is to appeal to the people that are experts, that are hackers, that know it well, and a lot of the times those people want information. So I think brands and products that are giving on-ramps and avenues for people to understand more about how their thing works so that they can hack it, those folks are succeeding, I think, early on. I don't think that a 3D printer is like a toaster yet. It's not the kind of thing that everybody has one in their home in the next 6 to 12 months. It is still a little tricky, and so the folks that make it easier for other people to engage, I think, are the ones that are winning. If that's just releasing models or opening up APIs and things like that, I think there's ways to just offer people ways to plug into what you're doing.
Do any of you guys have questions or things you want to share with each other? Something that maybe you've heard or wanted to point out, or something that enlightened you about one or the other on the stage? If not, consider it. Future forward.
Maybe we'll defer to you guys for this next one.
Yes. What about you, sir? Just step up.
Yeah, I've got a question. I know this is kind of like a hardware forum, but I kind of hear an underlying theme of like a lot of early funding coming from SBIR type grants. So do you have any like advice, or have you picked up anything? Because I know a few of you have like done that a lot. So like how a hardware company could go down that path of starting to navigate like tackling big SBIR grant applications.
Go ahead, Scott. Yeah, definitely. Apply for the grant. Apply for the grant. Apply for the grant. Nobody applies for the grants. You look online. SBIR is Small Business Innovation Research. It's the grants that are given out when Obama wants to give $6 billion to small businesses. He gives the $6 billion to the SBA, the Small Business Administration, and the SBA uses all of these federal agencies to actually give out the money and vet who's going to give it. So the National Science Foundation gives out SBIRs, the Department of Education gives out SBIRs, there's a bunch of them, Department of Transportation and stuff like that. And the SBIR grant process is as follows. You write a 40-page application. It's onerous. It takes like 100 or 200 hours to write this crazy application with all this stuff. You send it in, you wait like 6 to 9 months. But then if you get the grant, they send you a check for like $200,000, and then you're eligible to do the exact same thing in another 6 months, and if you get that one, they send you a check for $1.5 million. It's free money. You have to write a little report at the end of the period saying what you did with the money. There's no stock, there's no equity, there's no anything. It's free money for small businesses in the USA if you apply. Now the catch is, everybody hears about this and gets excited, writes it down in their notebook to go back and like do some research on these SBIR grants, and they find out on the web that only 1 in 250 applicants get the SBIR grants, and that's discouraging because it's like 200 hours of work for 1 in 250 chance. But as a consequence of getting these awards, we get to go to review panels in Washington, D.C. and review other people's applications who are applying for the awards, and I've done 6 or 8 of those sessions. I'm sure you've done many of them yourself. Turns out, half of those 250 applications are totally incomplete. Half of the remaining half, thanks, we'll keep winnowing it down here, he'll keep track. The other half just don't match the solicitation. It's like a stock proposal that somebody wrote for something else and sent it in for this SBIR award, and it doesn't match, so everybody just tosses it out. Another half are like applying for a grant for education awards. Well, half of half, so I've lost track of where we are, but like another half that's like an education award and there are no teachers on the team. It's like 3 engineers trying to do something for education, and you get 7 smart people in a room and they're like, I don't know, they should probably have an educator. When it comes down to it, you're competing with like 4 other people for all this money. It's like 4 smart proposals. So my encouragement is find the solicitation, apply.
Yeah, I would agree. I think it's a great program, great opportunity. The key is to have the right team that can actually deliver on whatever it is you're proposing, to find some kind of an unmet market need, and then to have the right letters of support. So when you submit it, you have a potential investor, a potential customer that writes you a letter that says, these guys actually are able to do this and it actually works. We'd be interested in funding it or buying it or working with it in the future. But it's a great program, and it is a lot of work. So if you're not going to be willing to make the investment of time to do it, I would not do it.
So I just want to plug the fact that VC is not the only way you have to go. We just recently applied for SBIR, so Eric convinced me it's kind of no strings attached. I was like, really? Wow, let's try that. But we have the resources to commit a person to write that paperwork, and it's not a small undertaking. So SparkFun, privately held, bootstrapped, started on a MasterCard. Right? You don't need VC. There are other methodologies. I don't know the statistics. All of them are made up on the spot. It's like 98% of businesses in North America are small businesses with no VC. You don't start a business with VC 98 out of 100 times, right? So don't think that you've got to go present in front of somebody and lose equity in your company. My little plug for MasterCard.
Let's just keep going with the whole script I had. I should have thrown it out as soon as you introduced yourself. What about you in the back?
So, which of you has any program to help us, like the new entrepreneur in early stage, especially getting into this hardware business? Because I know it's so many things that can go wrong, and there's so many regulation, FCC, UF, that we need to handle. So, for us at early stage, this is like overwhelming. So, anyone who has kind of program helping mentoring or those kind of thing?
I don't want to be Debbie Downer. I had nobody when I started. There was no outreach, there was nothing. Right now, there's these thing called the hackerspaces. Go to a hackerspace, talk to people. But one thing I want to point out is it was year number 3 before I had an accountant. It was year number 4 before I had an attorney. Right? Don't think you have to have all this stuff lined up before you turn on your Etsy platform. Like, just start selling stuff. FCC, they don't care, right? Like, don't worry about it. Once you start shipping over 1,000 units, then you need to care. right? But don't think you have to have all your ducks in order before you go get your certificate of sales tax revenue license thing from the state capital. Just go get that piece of paper and start selling.
Unless you're actually making toys.
For kids.
More regulated devices. or filing a tax return at the end of the year.
Yeah, just to touch on, the barriers, there's, a lot of times there's not many barriers. I mean, highly regulated, there's some serious issues that you have to it's just start building stuff, start trying to make stuff. I had a mentor before I got into acoustical consulting, and he died. And it kind of threw me back. And he was like a kind of a guru in this whole area. And nobody was even close to being like him. So I just had to muck through and kind of learn it. And then after that, then you just start networking, and your network builds. And with the open source community, that's one of those things that there's a lot of information out there. There's a ton of information. I think one of the things, even at Denver Startup Week, is there's a lot of noise. There's a lot of people doing things, but are they actually building something that's unique or innovative? That's a different question. And it's rising above that noise that's important. And a lot of times, I like to experiment alone. I don't like, unless I've finished an idea or something like that, then I'll show somebody, but I like to experiment alone. I don't want everybody distracting me when I'm actually doing the kind of experiments and different things that I'm working on. It's just my take.
Just get out there and start selling. If you got a product, that's great. If you don't, get an order and then make your product, and just get out there and get started.
One just little tip on the FCC and UL and all that other things. There are like tiers of labs also. So, you can go to some of the most expensive labs where you get your actual certificate and they hand you a sheet of paper and they're like, here you go, you're good. But there's also lower tier consultants and things like that can get access to space, that can do initial testing to give you an idea of how much noise your machine is putting off and things like that too. So it's not just like a binary, I'm fully compliant with every electronic regulation on the planet, or I'm hurting kids and stuff. So there are steps that you can take, and universities often have great resources for things like that, and they said hackerspaces. So there's ways to kind of dabble, and then with that consultant, they can often provide advice and counsel and say hey, this number seems unusually high, you should check this. So there's ways you can pay without having to spend all your money on testing.
Let's keep it rolling. Sir?
Yeah, hi there. I work in the semiconductor industry, and for the guys using electronic components, what are the biggest issues you guys have dealing with the major semiconductor manufacturers? Might it be an access to their technology, or a lead time, or a price war, US versus Asia, or something like that?
Yes.
All of that?
Yes.
Can you be more specific for me?
Just kidding. Just kidding.
One of the things that's really hurt us, that's been really tough to navigate, is minimum order quantities and then NCNRs, where you have to commit to a certain number of parts. So when you're a small startup, you have no idea how many you're going to make. You have no idea where your business is going to go. Maybe hopefully you get better and better at that at time. And most of the large electronics companies, Future and Arrow and everybody else, want you to sign these NCNR agreements, which are saying you're going to use 20,000 amped RF Bluetooth chips over the next 2 years, and you end up using 12,000 or something, and then in 2 years you get a bill for $67,000 that you weren't expecting. And so it's really hard to jump into that game as a small startup and navigate those waters.
Something we've experienced is the semiconductor industry still doesn't understand us. So my company wants to buy 5,000 of this barometric pressure sensor. That sounds like a lot, unless you're the barometric pressure sensor company, and they've got contracts for 1 million units with Samsung, 10 million units with somebody else. 5,000? That's a rounding error. We can't even answer the phone for that. So I have to beat down their door and say, I want to buy these 5,000. And they're like, okay, what's your application? And I'm like, I'm going to solder it to a breakout board and sell it to 5,000 different people. And they go, what the hell are you doing? And I say, well, I'm going to generate 5,000 potentially high volume customers for you, right? Each one of my customers is going to use this sensor, and then they might go build something that they themselves need 10,000 units of. but they don't yet understand that. So that's our greatest challenge with the semiconductor industry.
Big challenges. Right, you, sir?
Maybe this isn't relevant because we've had a whole bunch of interesting things occur, but I haven't heard the words hardware revolution said yet, which is the name of the talk. So I'm wondering maybe if you could say what that meant to you when you were asked to sign up for it.
Doug, why don't you start? Yeah.
I wanted to have something that was provocative and have people ask that question, because I believe it is real. You know, just had a talk yesterday. It was kind of funny. After the talk, somebody else said, here's this little drone coming down. And it's like, okay, there's one thing. And then, you know, obviously 3D printers. You see a lot of these, well, you know, just even taking account of both these companies here, even Sharklet. I mean, you're almost like backbone companies. You're like platforms that you can create all kinds of things, and creativity can come off these things. Obviously, yours is more the, you know, toy space or whatever, but there's creativity coming off that. Those kids might build electronics later on, or people in general, introduce people to electronics. So I was thinking, well, there are some really cool, they're offering some really cool services and products. You look at drones, you look at 3D printers, these are revolutionary things. You look at all the chips that are available and how small they are and how low power they really are. It's amazing, and what can be done with that. I mean, you know, one of the things that inspired me back in the day, and I've kind of circled back even looking at what all these guys do, is the K2 skis, when they had a kind of vibration feedback system, where they had a stack array of piezoelectric transducers that would cancel. Yeah, and I always stuck that in my brain. It's like, that is the coolest idea. And I see there are possibilities with that, and that's kind of what we're working on. Is we're looking at kind of a transducer platform that can be applied to stuff like that, and applied to like Windows and different things like that. And so there's just, I see just endless possibilities of core components that we can turn into something that's remarkable, like drones, like 3D printers, you know, you name it. There's some space talks here. There's micro satellites, nano satellites. That's awesome. I mean, that's really amazing. And we have the opportunities to go into space as civilians coming up here more. That's amazing too. That's hardware. That's serious hardware.
So just to kind of like borrow from the sort of early America colonial phrase of like a republic, if you can keep it, like there's a hardware revolution happening if you keep it, if people keep pushing the envelope. People are creating equipment to solve problems because someone got frustrated, annoyed, or they saw a better way, there was a feature missing. And so the revolution to me is the democratization of access. You can get a prototype made, you can have batch PCBs made for less than ever, you can do electronics, schematics, drawing on your computer. You don't need to be an EE to do that. So the revolution is happening, but you know, what's interesting is that is the democratization or the widespread access to it. And it will, in my opinion, only remain interesting if people keep pushing the envelope and trying to find new things. There's an example of a company in Brooklyn, New York. They basically make brain-computer interfaces. It's called OpenBCI, and you can use their headsets to measure brain activity, heart rate, and muscle movement to control devices, control prosthetics. I mean, things where I wouldn't have imagined, and their product is a couple $1,000s, and the market they're competing within, those products are many, many times as expensive. And so it's a revolution, a hard revolution is happening if your eyes are open to it. If you see an area where it's like, why is that so expensive? Or like, why does that work so poorly? Why can't someone do it better? Basically, you don't really have an excuse anymore. If it really bugs you, you can solve it. But it's only interesting if people actually do it. So hack stuff, basically, post your hacks online, then the revolution's alive, in my opinion.
So the hardware revolution, as I see it, is I'm an electrical engineer, and senior year, the senior projects, capstone projects, it was like an MP3 player and a hard drive controller. It was, wow, these are electrical engineers are going to create the same crap every year. The revolution was when we brought in all the other creative people, the digital artists, the folks that originally developed Arduino. It was a design art school. And now we have this huge tribe of people that aren't just electrical engineers. And so the fact that we're in this room talking about hardware shows that is the revolution, right? It's more people playing with this stuff that aren't necessarily electrical engineers. So we have, at SparkFun, every week we have Crazy Customer of the Week. And it's the story that gets told by our customer support staff about the crazy customer that called in that week. So last week, we had a gentleman call up. He said, hey, I need help adding a sound effect to my car. So when I open the door, I want to have the transformer noise, that's the theme song play whenever I open up the door. So we're trying to help him work through this and whatnot. And as we're helping him, he's like, oh, I'm really sorry, I have to go. I just pulled someone over. We went, I'm sorry, you're a police officer? Yeah, on the phone, pulling somebody over. And so the hardware revolution means that we're getting technology into hands that they're going to create stuff that, yeah, it's going to be silly, but there's going to be all sorts of stuff that we never would have seen because it's getting into the hands of really new creative people and not just boring electrical engineers like myself.
I'll put a little like a womp womp down on the hardware revolution since you know, to balance it, because we're all so excited about the hardware revolution. It's televised. You know, the hardware revolution, as I mentioned before, like modular robotics is here because of 3D printing. We're making tiny robots for kids. There is a hardware revolution. It's crazy the shit that you can buy on Amazon these days. But our story recently has taken kind of an interesting turn. We were bootstrapped and self-funded in SBIR up to 2012 when we decided to go get some venture capital funding, and we got it from the Foundry Group in Boulder, which is the best VC firm in the world. And Common Wisdom said, okay, VC scaling up, going to be a $20 million company or something like that next year. You got to go to China and get your stuff made instead of making it yourself in Boulder like we were doing and like we are still doing now to make everything in Boulder. So I got on a plane, went to China, visited all these contract manufacturers, and was kind of like deeply dissatisfied by what I saw. Not for the reasons that you might think, but for the reasons that it seemed like we could do it ourselves. Contract manufacturers have 3 tiers. There's tier 3, which is kind of like dirt floor. There are 5 people on every injection molding machine with hair dryers getting flash all over the place. And tier 2, there are fewer people. And when we started to go to the really good contract manufacturers, Foxconn and Jetta and places like that that make the devices in your pockets, something weird happened. We saw that there was nobody on the assembly floor. The lights were off and everything was robotized and automated, and they were just pumping out widgets. The cheap labor is in Myanmar and in Vietnam and in Malaysia right now, not in China anymore, so everything is becoming automated at high-end Chinese contract manufacturers. And on the plane back, I thought, well, if they're going to build a robot assembly line and they're not going to use cheap Chinese labor, well, we're going to build a robot assembly line and do it in Boulder, Colorado, and it's going to be totally awesome. And we've been working on that for 4 years now, and it's super hard. It's super hard to build a robot assembly line. Consumer stuff is a little bit easier. Robotized assembly is a whole ball of wax. And as such, now we're transitioning to making some of our stuff in China because we just can't compete on cost. So the hardware revolution is real. We're right at the beginning of it, but hopefully there's going to be a lot more and a lot more cool stuff happening over the next few years.
Yeah, in the medical device space, the hardware revolution, I mean, all that machinery that's trying to talk to each other, that's trying to care for the patients, continues to escalate. All the companies are trying to figure out how to make all that work. If you read any of the futuristic, they're not that futuristic, but the next 20 to 30 years, they're supposed to be able to create little nanobots that you inject into your body that run around and basically heal you and fix whatever's wrong inside. So I think that's coming crashing just right into the medical device space. For Sharklet, our goal with this wound healing device is to create a 3D printer that can, or work with somebody to spec out a 3D printer that can essentially be put into every hospital and every burn unit that can print these wound healing patches for patients. So we've kind of been pulled from a manufacturing perspective right into that realm as well. And then as far as the name of the panel, I think that maybe ski porn was already taken.
Yes. Folks, we're going to put a stamp on it right there. We've come to the end of our time here, 90 minutes. A couple things. First, I wanted to say how humbled I am, if not invigorated, to sit here on the stage with you guys, and also in front of the rest of you. This was super, super interesting, and I suspect that it must be amazing to be an employee for your companies. If not, it must be amazing to be a user of your products too. It's just awesome what you guys are doing. I'm sure you guys would agree. Also, Doug's brother Nathan, I think he had to step out, but he notified me mid-session here that Denver Startup Week has broken another record for registration. Registrations, I believe the number was 12,500. I know last year it was super significant when they broke 11,000. So that goes to say that the participatory engagement element of Denver Startup Week is only on the rise. And when you have content like this and storytelling like this, that's no surprise. So, I encourage you to seize the day, every day. Have a great night, a great afternoon. And thank you all. These guys are